Hello everyone, I am George Maximus and I am presenting driver drowsiness detection based on Humantenna effect for automotive safety systems. The authors are Henry Towers and George Maximus. This is the outline. First, I will start with the introduction. Available commercial driver drowsiness detection systems. Our proposal, operation principle and design, experimentation and results, conclusion, and finally references. Introduction, motivation. Drowsy driving is one of the most dangerous distracted driving patterns and considered as a permanent cause of injuries and death. According to the European E-Survey of Road Users Attitude, ESRA, most surveys concluded that the driver who suffers drowsiness is seen as the main cause of accidents. Moreover, about 36% of motorway accidents in Europe is attributed to driver drowsiness. Nowadays, the automotive industry tries to minimize the car accidents by integrating various sensors such as the heart and respiration in car embedded non-intrusive sensors, Harken, Gettysburg sensors, driver alcohol detection system for safety, DAVSS. Harken, the heart and respiration in car embedded in non-intrusive sensors, Harken, are based on the detection of cardiac and respiratory rate through embedded sensors in driver's seat and seat belt. However, there is a complexity and cost in designing the Harken. Gettysburg sensor. In Gettysburg sensors, the drowsiness detection is done using flexible sensor or bend sensor that measures the amount of bending. However, the performance of sensor is highly dependent on the temperature. Hence, it is required to evaluate the values of resistance along several areas of the steering wheel. In DADSS, Driver Alcohol Detection System for Safety, a new approach to measure the concentration of the blood alcohol is introduced. Its operation principle is based on touch sensing system that uses spectroscopy in order to measure blood alcohol concentration in the tissue of the driver's hand. However, it takes more than 2 hours in order to detect the alcohol concentration, and additionally, it cannot detect driver drowsiness, which doesn't involve alcohol. Our proposal: this work presents a cost-effective touch sensor integrated within the whole surface area of the steering wheel. This integrated touch sensor is based on Humantenna operation principle that can detect the presence of human hand on the steering wheel. The Humantenna sensor can detect a human only in 3D dimension. Also, it is cheap sensor and there is no complexity in hardware. The main idea of the proposed sensor is to harvest the induced voltage, which changes with the strength of hand grip on the driving wheel. The sensor is designed to yield a higher voltage value in case of loose hand grip, that's say indication of driver drowsiness, and then an alarm system is activated as a warning for the driver. This is a schematic of the proposed signal processing stage, including an amplifier composed of two bipolar junction transistors, BJTs, to produce the necessary voltage gain to activate the microcontroller. This operation sensor design, this touch sensor is integrated within the whole surface area of the steering wheel by rolling the wire electrodes over its area. The controller and the alarm system should be placed somewhere in proximity to the driving wheel. In case of driver drowsiness, the hand grip on the steering wheel tends to be loose, which produces weaker touching effect, and hence the controller identifies drowsiness event triggering an alarm to warn the driver. Several experiments are carried out to find the effect of hand grip pattern of the driver on the output voltage of the system. The grip strength is classified on a scale from 0 to 5, where scale 0 refers to loose or no grip, and scale 5 refers to a tight grip. 4 volunteers, 2 males and 2 females, have agreed to participate in these experiments. This figure shows the relation between the grip strength and the corresponding output voltage. It can be clearly seen that the grip strength can be distinguished based on the value of the output voltage. Accordingly, in case of driver drowsiness, the driver wheel grip becomes loose as the driver starts to lose control, which corresponds to the higher output voltage indicating driver drowsiness. The advantage of our sensors: cost effectiveness due to simplicity of the proposed sensor, no interference with the driver's activity, real-time operation with instantaneous response. Conclusion: a novel system for driver drowsiness detection based on Humantenna effect was proposed to be equipped in automotive safety applications. The proposed sensor is easily integrated within the surface area of the driving wheel, with no need for special equipment or arrangement. Based on the strength of hand grip on the driving wheel, a corresponding induced voltage is recorded, indicating the status of drowsiness. Different grip patterns for different male and female individuals have been examined. The measured induced voltage was proved to be an effective indicator of grip strength on the driving wheel, and hence drowsiness detection. In addition to its cost effectiveness and simplicity, this sensor is passive, requiring no receiver or transmitter. These are the references. Any question? Thank you.